talking to this one, click with this one. How's that? There's a kind of an irony here, because I think I'm probably the guy who understands the least about Puppet in the group, and yet I'm on the stage with the microphones. What's wrong with this picture? I want to just start off. I'm afraid we have to do an advert, but then I'm keep it entertaining as I can. And quickly, we just want to talk about the big picture, what it does, and why our Puppet environment might be different from yours. Just to give you the context about how our Puppet works. I think you've probably met these guys already. We've got 3 more back in Amsterdam, keeping things ticking for us. And possibly this is the advert you did. If you're busy writing your CV to send to TomTom, well, perhaps you'd like to send it to us as well. We've got 300 employees in Amsterdam. There's 100 guys in Chicago and Sydney as well. They're fairly independent offices, a lot of people moving about between them. And in each one we've got our own Puppet instantiation. So it's a great place to work. Lots of perks, lots of money. It's a very sociable environment, very friendly. There's always some entertainment going on. Right, that's it, thanks. Now back to the proper stuff. What do? We've got a big bag of money. We take some brains and we turn it into a bigger bag of money. It's a really straightforward plan. And it's quite elegant in a way, do you know, that we don't actually make a product, we just get paid for having money. I wish I'd thought of this first. This is how it started. We had 2 guys waving their hands in the air, but they've been kind of made obsolete by all this kind of stuff. So there's no longer any people waving their hands and trading anymore. Really. There's some guys for the newspapers in New York, but for the TV news, but they're pretty obsolete. So the big shouter guys are gone. Most of the top traders at our company are just really nerdy guys who can think numbers really quickly. The IT guys are quite nerdy as well, obviously. They're on equal footings. The companies realise that if you're going to make money and stay competitive, you have to be equals. So what we do specifically, does anybody know? Is the M&A guys into it? Market making. I talked to you yesterday. We were really struggling to find a picture. It's very hard. We are on the exchange all the time, and we guarantee to always trade. So that's our job. We've made an agreement with the exchange. We will be there. If you want to sell Shell shares on the seashore, then we will do that deal with you. Whether the price is going up or down or sideways, we're always there. So we make our money just by making the spread between the buy and the sell. And we're always trying to make a complementary deal. So if you want to buy something, then we'll be busy somewhere else trying to sell something to match it. So we never take a position. We never think Shell is going down. We're always, yeah. It means that all the mess at the moment is not really our fault, honest. We're kind of the good guys in that we're providing liquidity. So if somebody wants to sell Shell, that's such a bad example. If somebody wants to sell BP, we will be there, and instead of the stock diving because nobody's buying, we guarantee it. So we smooth out the market. We've got a strong ethical policy. We believe in a fair and level playing field and stuff like that. And because we're able to be fastest, we always do the deals. That means we've narrowed the prices because we want to be trading all the time. So instead of the buy and the sell being this far apart, we brought them down so that in the middle, which makes it cheaper for everybody to trade. And just a kind of a war story from the olden days. Because we're doing these trades in two halves, we started off with guys over here doing one trade, and then in Amsterdam they would run across the hall to do the other half of the trade over there. And a long time ago, way before Wi-Fi and stuff like that, we were the first people with a little computer who would send the information, do the other half. So all the other competitors would arrive all sweaty, and we'd have already done it. So we've just kind of kept that up ever since. We've tried to stay ahead.
I have a question.
Yeah.
Are all the markets visible, or is there some internal matching for big parties that not all people can see?
We really want to move everything onto the exchange where everybody can see it. There are dark pools, but we don't think that's really fair. So this is when I started at Optiva 4 years ago. We had our computers in Amsterdam, and the exchange computers are in Frankfurt, which is 446 kilometers. And this was fine until 2004 or 5, and we started to lose money because people were faster than us, because the price would take too long to travel along the speed of light along the fibre optic cables. This was a bit annoying because you can't really make light go much faster. So now everybody has moved their computers to Frankfurt or to London or wherever the trading locations are. And this is where we are today. Lightning has a speed, and if we see an event on the exchange, we've got sort of 10 meters of a lightning bolt moving before we have to reply. That's the environment that we have to operate in, which brings a lot of pretty cool technological problems that we have to solve. Like GPS clocks, maybe the TomTom guys can talk about this. We have to, well, there's lots of stuff. I don't want to get conference jacking or something. So let's get back to Puppet. That's the big picture for me. I'll take questions afterwards if anybody wants to talk.
Okay, now we're getting to the interesting part. Okay, you get yourself like a bunch of enthusiastic traders, and trading in a sense is, he said it's like in the speed of light. It's a very ad hoc situation. Traders, they can at any moment decide to change technology, to change the project, to change anything on any specific server, for example. And that's why I say PuppetCamp can be handled with our base. But we've got another problem, like in normal organization, financial institution, like a financial thing is like important, so you got yourself accountants. We got another type of accountants, we got CPU accountants, like the guy over there. Like, if the moment I start stealing too many CPU type cycles for my sysadmin job, it will drastically impact the performance of the training applications, meaning that my system administration things will simply be kicked out of the system. And they'll probably never get back. In that way, we actually made Puppet place in a Optiva where it's actually a way we use it without any demons. But we do, however, need the flexibility to change things instantly. It's also a place where every machine is uniquely increased. Like everybody got classes and everybody got a whole bunch of machines doing all kinds of the same things. It's like a MySQL cluster, it's like a web cluster, you've got yourself another cluster. In our environment, every machine is their own little baby. You can, in Puppet terms, you can actually say it gets its own little class. And we got a whole number of things where how we use to work around that. And what I said that changing to be applied in split seconds over here. So the moment the trader thinks this sysint just setting on the network interface card needs to be applied right away, we are the guys actually going to do that. Puppet one time is an alternative for our Puppet run. We don't like a daemon, so what we actually did, we split it up in two things. We have ourselves like a cron jobs. The cron jobs runs at night. Trading is a cool thing because the trading markets close at, for example, at 6 and they open at 9 in the morning. Any time spot after that, you can do whatever you like, whatever you do. So we do two independent trading runs. And we do that using some little trick, which people might know to spread the load on the server. So what we do, we first we hit it on a specific location, say 3 o'clock. We back off like a random set of minutes between 0 and an hour, and then we just start to do our Puppet trick. In this way, we can actually use many servers on a very small set of Puppet machines. Because we use around 400 machines in one Puppet server. We used to do it with 2.4. We used to do it before that, and it's working fine even more. It's now working even better. We also have Napios, and that's actually checking for Puppet existence. And it's not the thing where it says that it starts alarming the thing that it's when it's not running, but it starts alarming when it's actually running. And when it starts running, then people start to run to us, and we actually are in big trouble. So, yeah, we better make sure that before the market opens, that all Puppet these were actually left to be open, or are having some kind of issue somewhere, like are going dead or are going to do something that will actually do like shoot them in the head. The nightly runs via Puppet, it's a 2 nightly run phase, and I will explain later on, I guess, about the 2 nightly runs. And basically comes to the point where we haven't come across a good alternative of making changes in the factor files and using the newly applied changes in the factor files and get those back to the master machine. We got an awful lot of class definitions, but the class definitions itself is not an awful lot. It's an awful lot of exceptions within the class definitions. Basically, every kind of knowledge and little thing we define in a class is be able to, we can set a variable, we can actually override or just negate the setting. So it's a kind of harsh and awful job for us to do the maintenance as well, because you can see a class, but knowing a class will never know what the expected outcome is. And I will maybe show you how we actually get the one. Yeah, we use the factor to gather every piece of information from the machine we can during the night, and the information varies from, for example, from the current state of the hard drive, what kind of errors does it have. Like we do a whole bunch of preemptive checkings beforehand. So during the night, we actually are fairly like equal to the machine and actually do a very big investigation whether the machine is going to make it through the day to the next step. And what you also see, for example, what we don't have to do is like dirty hacks with people might not like. This is in an ERB file, it's like dynamic variables. But that's the thing if you don't get the razor. When it comes to the split second deployment, the Puppet one time is actually wrapped around the script. And what we actually do, people can just use SSH and can SSH to the machine the moment you SSH to the machine and the command will auto-execute, and you guys know the drill. And that will actually call Puppet one time. This allows the operator to say, like, I know the risk that there are going to be some CPU cycles to be stolen, but it's worth the risk or this needs to be done, so do it anyway. And the operator is also allowed to do data hacks. It's a kind of weird situation in an environment where you can say, yeah, I actually don't care very much about a consistent environment. And we actually do. It's like people are freely allowed to do any kind of changes on the machine. However, we like to say, like the next day we started trading, those changes all have to be reverted. And yeah, that's the thing we really like about Puppet. Because we say for Puppet, like Puppet is maintaining a certain set of files. We can say to people, you are allowed to make the changes. The changes will make it throughout the day. But be online. If you want to make it permanent, just let us know. And we try to be proactively in communication, for example, that we change the setting back. We're trying to track a change to a certain person on the machine is always a hard job, and yeah, we're still working on a good way around that. And of course, using OGS, don't like the name for the inline replacement of the mission critical files. And because a whole bunch of files are, people kind of know what they do, they kind of don't know what they do, and they say, yeah, you can change a few variables. You can change this one, this one, this one, this one, this one. But if you got these other files, they're really going to kick you in the butt. And believe me, traders can be, they can get pretty enthusiastic. It's a nice float, but they're really got passion for that job. And yeah, you will see that in the mission as well. No, this is a kind of normal situation. We use Subversion, we don't use JIT. We use Subversion for a reason. The field like to make sure that everything is centralized. Centralized is done before for compliance reasons. The moment you centralize your logging, the moment you centralize your configuration, you can actually ensure that the centralized location is the truth and nothing but the truth. The financial guys, the financial institutes, which actually are checking our, for example, logs or our configuration or checking for permissions, are very much more happy than using a distributed environment like JIT. The factor details are synced, and we also use the factor details to verify those against a whole bunch of other external databases. So, for example, we got ourselves a serial number from the machine. We get the serial number, we fetch that to from the CMDB, we get the location of the machine. We also know the network address. We also know what kind of network addresses are located in certain switch in a certain location. So we match the information within the CMDB against the information known from network. And if there is any error within any of those databases, which are technically speaking not our responsibility, we still just warn people saying like, hey, you guys might want to check this, there's something weird going on over there. Because this way you always know, for example, like, when you are in the environment, you are looking at the big picture, you know what you're talking about, and you know that the big picture is actually the thing that currently the way it's supposed to be. The database details, that's this one. We made a loop, because I have heard a whole bunch of like presentations, and people actually say, I've got myself a fixed set of settings, it's either in LLOP, it's in a file-based database, it's somewhere else. Then I build Puppet classes and variables around it, and I put it on a server. What we actually do, we heavily use Factor, and we put this Factor in a little Django app. It's not that legal anymore, but the Django app actually allows us for the regular use, like that will be an operator, but also will be the traders, it will be the network department, to like instantly view the current information about their infrastructure. And this way they can view the information, and what they can also do, they can make changes. So what they say, I'm going to deploy, I'm going to change this machine, so they can make changes in the Django app. And the Django application has got logic defined, for example. If the operator says this machine got to be a MySQL machine, and it used to be an Apache machine, then the Django app, together with this error, will have some logic in order to redefine the class variables and regenerate variables and classes. But we don't push that to the machines instantly. We just push those changes into the Subversion, and on a nightly basis, so before we get home, actually one of the operators, one of the Puppet masters or one of our five actually check those settings and make sure that the settings which they're going to be applied is actually the way people think they're going to be applied. Because there's like, you get yourself a level of virtualization, like how you're going to present the things to the user. But we want to make sure that the thing we're actually going to push to the server is the thing we're going to present to the user. So we try to get feedback from them, is this really the way you want it to be? And we also make sure that if we do the changes, that the user is informed that, for example, the machine will also be changed. And the fixed settings, those are external regulations. So, for example, if a regulator says this file has to be a certain permission, it's going to be a fixed setting. If even architects say like this machine cannot have this kind of package installed, it's a fixed setting. And the nice thing about Puppet is you get all kinds of conflicts the moment you got duplicate things there. And we actually use this use this information to make sure that people cannot do the things they are not supposed to do, or the other way around. That we actually enforce people to do things they are wanting to do something else, because that's if you give somebody a machine and you give them too many knobs to tweak on, they will happily turn on every knob and then find new ones. It's too bad. Or too good, that's the thing you might like. And the users actually do like the Django application. This is a little snippet, and of course it's financial though, so you see a whole bunch of white spaces. And what you actually can see over here, there are a whole bunch of little icons. There hasn't been any GUI design on this. That's a system doing what he thinks is the way it should be. And the thing we decided to do does all kind of linking. So the linking is like integration with other systems. Like, for example, this is like the red issue tracker. Are there any issues related to the server? This is a cacti monitoring, and also major PMP monitoring. There's more integration. Like, for example, the current state of the backup. This is also an icon over here that says that this machine has been backed up properly, or this machine has not been backed up properly. And for example, the backup operators, they can generate overviews and they can immediately see, like in one blink of an eye, without going to the backup system, which is not very nicely proprietary piece of junk. They can actually see a nice overview which say, like, this is the thing, this is the procedure, it's not like, not backing up well, and there has to be some action with it. And same applies to routing details. For example, there are changes in the machines. Is this change allowed, or do I need to approve it, or do I need to change anything on the machine, or do I need to send in a request in order to make it consistent? And you get a whole bunch of information like network interface information, system interface information, etc., etc. And the reason we choose Django for this bit, by the way, is the fact that we can keep it close to our way we actually define the Puppet definitions. Because the nice thing about it, they got both the notion of inheritance, they got both the notions of classes and linking together and all kinds of bits and pieces. So we actually use the Django to make some kind of viewport. So we also use the Django and to actually say, like, if you got a certain rule, say for example include Apache configuration disable boot or something like that. So much fun. This is as Lucas said, if you like to be here, it's a pretty tough job. It can be done in a few days. You just got to do a technical test. And I promise there will be questions about Puppet in there. And you're gonna have some interviews, and step 3 is depending on the outcome of step 1 and 2. I've been very briefly walked through the picture, and I'm not sure whether someone would like to know somewhat more about a specific component or department or error, or any other general questions.
So, way back, you mentioned that you're going to objects for inline notification of config file. That was how you give the users the steps to modify that tool.
Now, when we actually use Codius and the inline editing to actually, because when a functional architects say the operator is allowed to actually alter this, and this flag, we use Codius to say to the user that if you set this kind of variable, Codius will actually change for you what the specific setting, and it will not change the other content of the file. It's like some variables we need to do an accounting on. They take, for example, log levels. Because we need to make sure that the log level is always set to a certain amount, and it cannot be 0. So we use, for example, Codius to check whether something is logging properly. But we then don't care about all the other ones, which are, for example, for development, a whole bunch of other extra lines which used for logging. Okay, thanks very much.